Okay. Then now, let's start again. Okay, it is my pleasure to introduce Professor Alexey Kuzmin from Universidade Federal do Rio Grande do Norte, and he will speak about free write alternative metabelian algebra of infinite rank. Okay, please, Alexey.
Yeah, it's really my pleasure to be here. Thank you to you all for this opportunity to present and to organize. I've heard lots of good words about the audience, and I'm one of those who share all these words. It's a real pleasure to present among you guys. Thank you, thank you. And special thanks goes to my colleague, Professor Artem, for who gave the idea and make it all possible to happen, who gathered all us here. So, shall we start? Free write alternative metabelian algebra of infinite rank. What it's all about. We got actually very brief plan. First, we're gonna talk here about the variety of right alternative metabelian algebras. Here we are then. Here is our main definition. Our field is actually a field of characteristic distinct from two, and this symbol means the variety of right alternative metabelian algebras that is defined by the following two identities. First identity is the identity of right alternativity. Second one is the metabelian identity. Here, as usual, we use the standard denotation for the associator. What can we say about this? Some known results. Let's go. First of all, this is the font of the examples of non-Spechtian variety over an arbitrary field. Characteristic distinct from two, it's just certain technical restriction, actually the result of Belkin from 1976 is true for any field. This variety is not Spechtian. Of course, we recall what it means. It means that we say that the variety is a Spechtian, we have the Specht property if every algebra of this variety has a finite basis of its identities. This is not the fact for our variety. Of course, we cannot forget that the questions about the Specht property of the variety of all alternative Lie, Jordan and Maltsev algebras are still difficult open problems. If somebody knows the answer, please let me know too. Here we are. In 1985, it was established that our variety of right alternative metabelian algebras possesses even finite dimensional algebras that do not have finite basis for their identities. Of course, there are also different kinds of results on sufficient conditions for the Specht property of proper subvarieties in this variety, and on non-finitely based right alternative superalgebras. Some of them are mentioned here. Some of them are mentioned here. Well, our second object is the free right alternative metabelian algebra. And here we are. over our field, we fix the following denotation. Let A be the three right alternative metabelian algebra on the countable set of generators. What is important here? What we would like to stress? Here? Actually, it's well known that A satisfies the following identity. This identity is called the right-Muffung identity. The right-Muffung identity. We can actually equivalently write it down for the associators the following way. And here we deal with the property that makes our associator to be the so-called right-Muffung function. It was to stress that the similar property holds for the Jacobian in the three modes of algebra. Here we have the Jacobian, and it's also have this property. It's right-Muffung function. Well, what we would like to figure out about this object as initial information. We consider the certain example, certain guess about how could be the base for our free algebra. And here we're gonna have some modest answer up to degree 4, just 4. So our initial elements are up to degree 3, and here we kind of say that it's clear that up to degree 3 one may choose these elements at the base. But let's be honest, we actually deal here with some natural try to establish the monomial base for our object, and of course monomials are linearly dependent. But if we do the following trick, if we choose the associator to play the part of one of base elements, we're gonna succeed. This is our initial example. This is what we have in degree 1, 2, 3. Of course, all these variables run our generating set, and also what is really actually important. What is really actually important is that we here from the very beginning adopt the strategy to use indices. We're gonna deal with something huge and something unpredictable, and we need some good tools. Our tools right away is to use indices only when it's really some skew symmetry, partial skew symmetry effect. Here we have this partial skew symmetry effect, of course, by our definition, because our variety is the right alternative one. So let's go on. Inspired on the right-Muffung identity, we introduce the following auxiliary function. And here, what we should stress actually here, the point is that by the linearization of the right-Muffung identity, one can really prove, and this is the exercise, that our function rho of 4 variables is skew-symmetric with respect to the last pair. Actually, it reminds the kind of a little bit generalized associator of 4 variables. Well, what else can we do about this? Of course, we don't stop here. We can consider similar functions, and we need the symbols in what follows for short. Just for short, we use the symbols of bar to mark the variables involved into the particular symmetrization of a given element, and similarly, the symbols of acute graph, it's called graph in English, are used for the skew symmetrized variables. And we give some particular examples here. As we've seen above, symmetrization with respect to axiomatic, with respect to skew-symmetric variables, the symmetrization will give us 0, and similarly, we just give the double element here. But if we do some like that with other pairs of our element, we should have the following. Actually, one can prove that the symmetrization of our element with respect to yz and skew symmetrization with respect to yz have the forms. Actually, the second exercise, we make it clear that it's not hard. We just consider by definition, and we have something like this, where, as usual, we use the standard symbols for Jordan product and for the commutator of given variables x, y, respectively. Well, what we do with this? We say, okay, we are ready to represent the base for the degree 4. Actually, we're gonna use 3 types of elements in degree 4. First one is just the associator, such that we use the product from left by the variable, just like as a given result. This is welcome, this is our new base element in degree 4. Second one, the associator, which possesses the commutator inside. And of course, our function that gives us some information basing on the right moving identity. And here we are. We got the product rules here. And this is, of course, is not an exercise. This is kind of theorem on this way. One can check that actually we have here the explicit product rules, and our base elements from degree 3 under actions of variables go to the following linear combinations of our elements who start after this, after we will verify, of course, all axioms of right alternativity. They start playing the role of base elements. What we can actually stress here, what capture here our attention. Sure, we got from left some elements T1 to 2. This is the skew symmetry, and we can see that it's inherited by the right part naturally. We also gonna notice something about the second formula, that Z and T also are actually gives us skew symmetric results, and we can see it by this formula. Okay, by virtue of the Kleinfeld identity, rather well known for specialist Kleinfeld identity in right alternative algebra, we can verify that this is true. So, and actually even we could stop here, but it's not our case. We gonna look at this the following way. If we continue, we have the degree 5, degree 6, and so on. Of course, we can succeed looking for some similarities, but maybe it worth to take a look from the other side. And this is what we do, kind of look from the other side. Square restricted multiplicative enveloping algebra. We introduced this notion here in these terms. It's clear that technically it exists a long time. And let's give some basic notion about this. Now, let M of A be the associative algebra over our field that we fixed, generated by the identical mapping and by all operators of right and left multiplication acting on the free right alternative metabelian algebra. What we know that usually this called it is called the universal multiplicative enveloping for our free algebra. Consider the algebra that we denote differently M star generated by the restrictions. Actually, the restrictions of all operators from our algebra of multiplications considered on the square of our free algebra, a squared. Acting like this, acting on the square, what we actually have, we can notice that it's clear that our algebra is generated by all operators of the form Rx and Lx, where from right and from left we act only by elements from our generating set of our free right alternative metabelian algebra, and of course the identical mapping is here is one of generators, and we gonna just use this term to define what we are working with, the square restricted multiplicative enveloping for this object, and of course we emphasize that this algebra is an associative algebra. Well, let's say something about this algebra. This is our goal right now. Basic operator relations. Actually, we stress that this algebra satisfies the following four relations that we call basic ones. As far as our goal is to find the complete base for our free algebra, and we are far from succeed, let's be honest, we go here from the associative side and we consider the relations. What we have here, these four relations actually follows from the define identity and from the right moving identity. Three last relations are exact consequences, different operator versions of the effect of right movement. Well, and when we work with this, we achieve the following. We achieve the following result. Our main lemma based on this operator says that our result of the composition when we use the product for any natural n, absolutely for any natural n, we consider the word that's not gonna be basic one, but it gonna give us the whole information about base E for our associative algebra. For any natural n, we can transform this word uniquely, basing only on operator relations and certainly without any difference how exactly we do it. Still, we affirm that the result is the following here. Delta, of course, it's to simplify our formula, works from naturals to the field. This formula is valid since even n natural n3, but even if one goes back to the n equal to 2 and says, okay, if this word is empty, we should stress, even in this way, the formula still works, because we look here. Here we have like a long consequence of the initial basic relation of skew symmetry of R words, of right operators. If you imagine that this word is just empty and look that the operators here just changed the position, make one transposition, you can really see how far we gone from the basic operator relations. Well, from here to here. And this is our main lemma that gives rise to the theorem on composition of operator words. Actually, we established 7 types of base operator words, and we equip them with the explicit product rule that have exactly 7 squared, its natural explicit formulas. And you know what? I think I should start here, and thank you. Thank you very much for your attention. Thank you.
Okay, let's start. Comments, questions?
we can write your comments and questions.
Yes. No questions or comments? Then, okay, let's just thank the speaker again.
Thank you very much. Thank you. Thank you.
Okay.
And we're gonna need some technical break again. We're gonna change the speaker from our room. We're gonna figure it out, and we're gonna be back soon. Okay?
Okay.
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 So just be here.
I'll let